cargo reliquefication unit on board of VLGC. Our ship have 3 reliquefication units, they are identical, totally same. Compressor is 3-stage compression. Our ship is 84,000 cubic meters capacity and 54,000 metric tons of dead weight. This is VLGC vessel, and we will start now explain how the reliquefaction system work. This is vapor line which is going from tank. All 4 tanks is connected now because we have propane, and vapor sucked by compressor, and first it's passing knockout drum or liquid separator. Inside this drum have float. In case the vapor is full of liquid, it will give alarm and trip the system. And by manual valve you can drain the liquid back to the tank. This is condensate, it's return liquid after reliquefaction plant. All condensate is going back to tank. Why it's very important and vital? Because compressor cannot compress the liquid. That's why only vapor must enter inside the suction of first stage compression. Here have like segregation, like separation vapor and liquid. If have some liquid, it will condensate, drop down, and after you drain to the tank. Okay, after it's sucking first stage compression, and compression will, suction will be around temperature -25 and around 200 millibar suction pressure, plus minus same like at tank. After it's compressed, this compressor is piston type, and it's making some work under the vapor and the increasing pressure. And vapor pressure after first stage compression, discharge pressure, will be 2 bar and temperature +30. Now compressor is not running, but I didn't have time during the running compressors shoot the video, but I will explain what is the temperatures and pressures normally we have at each stage. After this hot vapor is going to next drum, it's calling economizer. Inside this economizer 40-45% full of liquid condensate, and when hot gas after first stage coming to economizer, it start interacting, and this cold liquid cool down the vapor, and some vapor is condensate and some vapor already cooled going to second stage compression. This making to avoid high pressure at suction for second stage. After second stage compression, it's around 6 bar and 40-50 degrees Celsius. And after it's go to third stage compression, and after discharging third stage compression have 100 degrees and around 14-15 bar pressure. This is 3-stage compression. Okay, after this hot gas, compressed gas is going to condenser. Condenser is heat exchanger tube type. Inside this condenser have a tube, titanium tube. Through this titanium tube going seawater. Overboard water is continuously circulating, and when this hot vapor is coming inside and touch this hot titanium tube, it's immediately give energy, give temperature to the seawater, warm up the seawater, and the vapor is condensating. That's why it's like circulation of energy. Water take energy from hot vapor, and vapor is condensating. And after this condenser, this mixture of liquid and vapor is going to receiver, liquid receiver or condensate receiver. It's also have float, and 40-50% it's filling, and after the valve open, it's go to vapor gas cooler. Vapor gas cooler. This also like interstage cooling. In case our system pressure is going high, it means our vapor have some incandescent gases. Incandescent gases, it's nitrogen, methane, ethane, ethylene, and if these gases will accumulate inside the condenser or vapor gas cooler, the pressure will increase. The pressure here inside receiver and condenser will be same like discharge third stage compression, will be around 14-15 bar. Also, the temperature of condensate you can calculate by formula temperature of seawater plus 8-10 degrees. It means if the seawater is 20 degrees, the condensate will be around 30 degrees Celsius. After it's going from receiver to cooler, cooling a little, and after it's going to economizer for subcooling. Here have small pipes on the bottom, and initially when you run only seal system, first condensate filling receiver 40-50%, after vapor gas cooling 40-50%, after economizer 40-50%, and only after it's open expansion valve and send condensate to the tank. And this stage, when the liquid and vapor mixture is coming to economizer for subcooling, have pressure same like third stage 14-15 bar, and after it's going to expansion valve. Expansion valve, it's working like expansion, it's open close, open close, open close, and after expansion valve it's immediately drop the pressure, and as per physics law, drop the pressure, drop the temperature. That's why when here we have before expansion valve 15 bar, after expansion valve we have 1.5 bar. And when this immediate drop of pressure exists, happened, drop of temperature up to -15, -20 degrees Celsius. And after this cold condensate is going to the tank. And when it's come back to the tank, you can see inside the tank we have 150 millibar. And after the expansion valve we have 2 bar. It means when the condensate will come to the tank dome, cargo tank, it will have also small expansion. Through this green line, we can send condensate or to the bottom or to top spray. And when the condensate will come to the tank, it will expand more, drop of pressure, drop of temperature. That's why this is all like connected to each other and very important in all this cooling reliquefication cycle. That's why I hope it will be more than less clear for everybody how our reliquefication plant working on board of VLGC LPG vessel. Now I explain all these temperature pressures for propane, because mostly LPG carriers, they carry butane or propane. Now we have on board propane, all tanks with propane vapor. Now our discharging in progress, we are discharging at Zhangjiagang port at China. Now as you can see, for example, our 4 port pump is discharging after 3 starboard, 2 port and 1 starboard. And we discharging port side alongside through the 2 manifold L2A and L1. Now discharging in progress, we already almost complete. No, almost, it will be tomorrow, but tomorrow my contract already finished, 5 months on board as a chief officer. It was pleasure and good experience, and I'm happy to go home. Thank you for your attention. All the best. I hope next ship we will continue educating, learning and improving our professional skills and knowledge about LPG gas carriers. Hopefully next my ship will be big a ton carrier, and I will explain something new and interesting for you. Best regards for everybody, guys. Bye.